Okay, hello, welcome to this walkthrough of Mastery Exam FB Practice Version 2. Like all the other Practice Version 2s, we're going to kind of go quickly through this, not going into a lot of detail on the steps here. If you need more detail, we'll provide some of that here. There's more detail in Practice Version 1 screencast on this exam, and you can just jot down your questions and ask your professor for more help too. So let's get into it. Give the domain of this function in correct interval notation. Well, I look at this and I see that we have a square root, and anything's okay under a square root as long as it's positive. So what I want is for this to be positive. So I'm going to start by thinking or 0. I would like any x that makes this inequality true is going to be in the domain. Any x that makes that positive. So let's solve that inequality. I'll add 3x to both sides and get this. And I'm just going to flip that around to make it feel a little bit better as I write it. And then divide by 3, and I will get an inequality that tells me what the domain is. To put that into correct interval notation, that's all x is less than a third, so my answer is going to be, I'll just put this down here, negative infinity to 1/3, and square bracket that off, because infinity is not a number, negative infinity is not a number, so you can't include it. 1/3 is a number, and that's the endpoint in my domain, and I want that included because this is less than or equal to, and so I have square bracket that off, and that's that problem. Okay, so now moving on to problem number 2, we have this graph of a function g, and we need to give its domain. I see that they start at -4 here, and I do have a graph there, and I have a graph everywhere all the way up until +4, but there is a hollow circle there. So the domain begins at -4, ends at +4. I'm going to include -4 because I do see a graph there, but I'm going to exclude +4. So include -4, exclude +4. The range of this, that refers to the y-axis, so the lowest I get is 0, right there and right over here. And the highest I get, I almost make it to 4, but not quite. So I start at 0 and end at 4. I am going to include 0 because I do hit a height value of 0, but I never make it to 4, so that's that. Clear the graph off here. And we want to know what's the value of g of -1. Well, let's see, here's -1, and g of that looks like 1.5. So 1.5. Lastly, we're looking at the values for which g of x equals 2. Where does the output equal to? I can just think of, here's 2 on the y-axis, and I see right there's a place, there's a place, and there's a place. That looks like around -3.2-ish, we'll call it that. Doesn't have to be perfectly accurate, but definitely in the ballpark. Here at 0, looks like I'm at 2. And over here around x equals 3, I'm at 2. So there are 3 places where I hit that output, and that'll do for problem 2. Finally, problem 3, let's classify these functions as linear, power, exponential, logarithmic, or none of these. Looking at the f of x function in part A, I do see it goes through the origin, so that automatically rules out exponential. It is not, when the x is increased by 1, the outputs are not increasing by the same rate, so definitely not linear. A logarithmic function doesn't increase at an increasing rate like this, and so that rules out logarithmics. This is either power or nothing. In fact, this is a power function, because I can actually see that this is, it is actually x cubed. I can kind of read this off now. 1 cubed is 1, 2 cubed is 8, and 3 cubed is 27. So it actually is a power function. Now on to the next one. Let's just get rid of the x's here and all the declarations I have. What kind of function is this? Well, it's definitely not linear because the x's are increasing by the same amount, but this function actually goes up and then down and then up again, and linear functions definitely don't do that. And neither do exponential functions. Exponential functions don't have turning points, and logarithmic functions don't either. And that rules out everything but power or none of the above, and this isn't a power function because power functions do not have 2 turning points like this one. It's 0 to 2, then to 1, then to 3. This is not a function of the form y equals x to the a for some a. If it were, then 1 would be sent to 1, because if I plugged in 1 into this function, I would get 1 out. So this is a none of the above. None of these. It doesn't have any of the characteristics of either linear, power, exponential, or logarithmic. And that will do it for this exam FB. Again, ask your professor if you have any questions about this information. Pause, rewind, and get it worked out, and keep working, and you'll be fine.